let's say, note about the set notations. Okay, so whenever we have, let's say, the intersection, the union, right? Okay, are you on?
Oh,
Hello.
sorry. Yes, I am.
Okay,
Sorry, I was on
perfect.
mute.
Yeah, so
Yeah.
the most important part, I mean, the tricky part, apart from whatever you know as basics, I mean, there's the something called the fee. The fee. So the fee may be the fee element or the fee set or subset. Okay, the fee notation is just for the empty. So the fee is the empty. It may be the empty element or empty set. Empty. So imagine I have a, let's say, 1 2. Imagine is, let's say, 3 4. Okay, so whenever I say the intersection, you say the empty element. Okay, the intersection is the empty.
So they don't match. There's no intersection. That's right.
There's no intersection. Okay. Now, you know the union, if there's any element repeated, you just put it once. Okay. Yeah, so basically this is the most important part within those functions. So number one, I guess there's no issue about. Yeah, you let me know if there's any. Okay.
Yeah.
Now for the second, the union, it's, yeah, for the 3 5 is repeated, for example, just put it once. Okay.
Yeah.
Okay. Number 3, when we say real numbers, so let me pass number 3 by notations and names of categories of numbers, right? So basically, numbers.
Yeah.
Okay, we have integers.
Sorry, you were very clear. Oh, now it's better. Now it's good.
Yes. Natural numbers, integer. Okay, so the natural is set n. Integers would be the set z. Okay, so this is z.
Okay.
Some would do it this way, capital. Okay, what else do we have? We have the quotient set, where sometimes the notation is the q. Okay, it's like capital Q, something here or there.
What's the quotient set?
The quotient is the rational. Some would say rational set. It's the rational set, the set of ratios, which is in the look of A over B, with B not 0.
Okay.
Okay, the ratios. And then we have the real set. The real set, the one that we are talking about in the here. So the real set composed of all those. Okay, the real set can be any number. Now, there's a set which is very special. We call it irrational. So this is rational. Rational means a ratio, but there are numbers that you cannot write as a ratio. We say irrational numbers. So this is composed in a set. We say irrational. The irrationals are in the look of radicals. Okay, and they are non-repeated. Non-repeated, let's say, decimal part. So the irrational is composed of the radicals, basically.
Okay.
So when we say radicals, it's not like the square root. It may be with an index, cube root, fourth root, whatever. Those are the radical notations.
Okay.
Those are decimals. I mean, the definition would be this: the decimals that cannot be written as a fraction. Decimals cannot be written as a fraction. But right here, rationals can be written as a fraction. Okay. So I can give an example. Let's see. 333 something. 0.
Yeah, that makes sense.
Blah blah blah. This can be 0.
Yeah, 0.3333.
Now this is 1/3.
30%.
You see, so this is a repeated decimal. We say repeated decimal. It can be written as a fraction. So this is a rational number. It's a rational number. Now 0.714285. Okay, and then this is nowhere. Okay, it's not repeated. It goes on. So we say this is non-repeated decimal. It's not repeated. So I don't see, for example, 5. I don't see 85 or so. Okay. So in this case, this is non-repeated decimal. Okay. This would be in the set of the irrationals. So this is irrational number. For example, radical 2 is, if you calculate, it would be 1.4142, and it goes. But it's not repeated. It's like numbers showing up that we don't know its what its formula. For example, pi is a rational. What is pi? It's approximate to 3.14. Blah 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 blah. Okay, you see those. I mean, the decimal part right here cannot be figured out. We don't know. So this is at random. Those would be at random. At random decimal numbers, we say this belongs to a rational. You get it? Anyhow, this is all category of numbers.
Yeah.
If you put all numbers like the natural, by the way, the natural starts from the 0, 1, 2, 3. Okay, they are all positive. The z, you have 0 in the middle, you have the positive numbers here and the negative there. Okay, but there are no decimals in natural and z. Okay, yours. And then we said we have the q, and the q are the log of a over b, but the b shouldn't be a 0. Because if b is a 0, then you get undefined numbers. When you have number over 0 is infinity, there's not a number. So b shouldn't be 0. Okay? And then we say irrational numbers. Now the irrational has no set notation usually, so we say irrational numbers. They are composed of radicals and composed of non-repeated decimal. And then all those together would compose the set R, which is the real. So set R is the set of all real numbers. Okay, the set.
Real numbers would be 1, 2, 3, 4, 5, right?
Yeah, whatever number you imagine, it is in the set. Whatever number you imagine, like the n, the z, the q, and the irrationals are all.
I see.
Some would say this is basic for numbers. Some would say that the n set, and if you collect all numbers, and if you collect the z's, so those the negative would add up. This would be the z. So you see, z. Now what comes more, if you have decimals, so here we don't, but if I have decimals, so the decimals would be out. I'm just making a demo in figure. You get it? So this is the q. And you have, so what's going on is like any time you can figure out a number that doesn't belong, this would be outside the circle. You get it? Why do we have z? Because the negatives are not in n. Okay, why do we have a q? Because the decimals are not in n and z, so they are outside. And someone would say, okay, what about numbers that like the pi, like the radical 2, those are not in q, not in z, not in n. So compose this is outside. And then imagine all those together would compose the set R.
Okay.
Now in 1970s something, that led to the technology revolution, by the way, and guess what happened? This a few knows about. It's like there's something new. I can give you a number which is not real. And this would be, can you guess? C? This is the C set. It is the set of, can you guess?
It's not the rational, the irrational?
No, the rational and the irrationals are all here.
Are
all up.
Okay.
Are all there.
Not the rationals. Rationals are real. Integer is any number. And then the quotient would be rational. And then there's the radicals.
Yeah, the radicals are irrational, but we are talking all the reals are right here, are up.
Yeah, all of them are.
I can provide you with a number that is not there in the red at all, not in R. So this is a new category of numbers. This is set of complex numbers. Now the set of complex numbers is a huge revolution in mathematics that led to the digital revolution. I mean, let's say telephones, mobiles, applications. So what is a complex number? A complex number basic definition that a positive is a negative expression. That is impossible. Impossible in real life, impossible in reality, impossible in art.
Yeah.
So we say this is complex. It's introduction to a complicated word, we say. So, but that led to a huge revolution in technology and in real applications, okay? So I square equal minus 1, as if you are saying that I equal radical minus 1, because if you go to your calculator and you put radical minus 2, it has no answer. It's an error, because radical always accept positive. Why that is so? Because this is a square root. Now, this is an introduction for all those.
Exactly.
Now, cube root accepts a minus. This leads to a
Yes, makes sense.
the square root with an even index. This is called index. The square root or index with an even index. This is
Can't be negative.
yeah. This is an error. We say this is an error.
Yeah.
Okay, the even index only accept, but the odd index accepts the minus as well. So the odd index has no issue. Radical or cube root, for example, cube root of minus is a minus 3. If you click your calculator, okay, you get this answer. What does it mean? It means if you multiply this 3 times, it's minus 27. Okay?
Sorry, I don't know why it was very clear before and now suddenly it started cutting.
Yeah, maybe I'm moving fast a little.
Okay.
Anyhow, so when we say, for example, radical 9 is a 3.